Let's dive into duplex and speed, the dynamic duo of network misconfigurations. Think of half duplex as a one-lane bridge, only one direction at a time, leading to possible traffic jams, or in network terms, collisions. Full duplex, on the other hand, is like a two-lane highway. Traffic flows smoothly in both directions simultaneously, with no collisions and effectively double the bandwidth. Ideally, auto negotiation should handle these settings for you, but when it clashes with hard-coded configurations, things get as unpredictable as your first cup of coffee. If you're shooting for that CCNA certification, you need to spot duplex mismatches and know how to resolve them. Pronto. Half duplex works using something called CCNA, which stands for Carrier Sense Multiple Access with Collision Detection. Think of it like being at a bustling dinner party. Before you chime in with your story, you check to see if anyone else is hogging the spotlight. If all's quiet, you go ahead and start chatting. But if you and someone else decide to talk at the same moment, it turns into chaos. That's what we call a collision. Both of you have to pause, wait a bit, and then give it another shot. Now, full duplex? That's like having a one-on-one chat in a quiet little coffee shop. You've got separate lanes for talking and listening, one just for you and one for the person you're with. No collisions to worry about, just a smooth conversation. In the world of modern switched networks, full duplex has become the standard for every port. Half duplex is mostly a thing of the past, popping up only with hubs or certain wireless setups. Duplex mismatches. Picture this. You're at a dinner where one person thinks it's a buffet while the other is dressed to the nines for a fancy sit-down meal. Chaos, right? That's a duplex mismatch in networking. One end is on full duplex, acting all confident, while the other, stuck in half duplex mode, stumbles around, causing its own traffic jams. This leads to late collisions on the half duplex side, and suddenly, your network's moving at a snail's pace instead of racing like a cheetah. On Cisco switches, you can spot these issues by checking the interface counters for late collisions and input errors. Solving it is like getting everyone to agree on a single dinner style. Either set both ends to the same speed and duplex setting, or let them auto-negotiate. Problem solved. Let's dive into some duplex situations that can trip you up during the exam. Picture 4 scenarios you need to keep in mind. First, consider collisions. It's those late collisions that you need to be wary of when there's a duplex mismatch. Early collisions, they're just part of the package with half duplex. But if late collisions show up, that's your signal that one side's full duplex and the other's still stuck on half. Now, auto-negotiation can be quite sneaky. If one side is set to auto and the other is set firmly on 100 full, the auto side might decide to go rogue and choose 100 half instead. Surprise! You've got yourself a mismatch. Cisco's 2 cents? Set speed and duplex settings manually for server ports. Why? Well, servers are like your best friends. You want everything clear and planned. User ports, on the other hand, can stay on auto. They're more like casual acquaintances. A bit of unpredictability won't hurt. Finally, let's keep straight the difference between speed and duplex mismatches. A speed mismatch? That's a non-starter. The link won't even come up. But with a duplex mismatch, the link's there. It just feels like you're stuck in rush hour traffic. We've just tackled the ins and outs of duplex and speed. We explored half duplex with CCNA, the art of full duplex operation, the magic of auto negotiation, and the ways to spot and fix a duplex mismatch. Now, why not head over to Courseiva.com, dive into some CCNA questions, and get that brain fine-tuned for success.